Dynamic response of full-scale hybrid concrete slabs reinforced with the steel bars under multiple free drops mass impact, presented by Ahmed, Altemen, Medhlom, and Mustafa Özakça. Impact loads can make significant damage to concrete slabs. Many researchers study to improve concrete resistance to impact forces. This study aims to study the effectiveness of hybrid concrete on slabs resistant to impact loads comparing to normal concrete slabs. A free drop mass impact experiment setup will be utilized to find the impact response of hybrid concrete slabs reinforced with steel bars comparing to normal concrete slabs. In this investigational study, one hybrid concrete slab and one normal concrete slab were experienced for free drop impacts. A full-scale 1550 by 1550 millimeter slabs were used. The hybrid concrete slabs contain 50% of reactive powder concrete with a reinforcement ratio of 0.006, having a grid of 8 steel bars, and the control specimen casted with 100% normal concrete slab with a reinforcement ratio of 0.00448, reinforced with 6 steel bars, have been made and subjected to 7-meter free drop mass. The outcome from present research demonstrate that slab casted with reactive powder concrete made a significant enhancement for enduring impact loads with much less dispersed fragments comparing to the normal concrete slab. Also, slab casted with the reactive powder concrete gave low deflection compared to normal concrete slabs. Here we can see the slab geometry. On the right is the control specimen with 6 bars, and on the left is the hybrid concrete specimen with 8 bars. Also, we can see the specimen details for the two slabs. Here we can see the test setup. The procedure begins with lifting the specimen by crane and attaching all the necessary gauges and LVDs and sensors, and it must be held by at least three persons to before release the mass on the slab. This part to present the visual observation of impact tests. The control specimen was subject to 2 drops at height of 7 meters. The first drop made like nearly 5 centimeter penetration, and the second drop made a full penetration. Still, the second slab, the hybrid concrete slab, made with 50% of normal concrete as a lower layer and 50% of reactive powder concrete as an upper layer, subject to 2 drops at 7-meter height. We can see all the results on these pictures. For the load deflection data, here we can see LVDT1 and LVDT2 for control specimen at failure. And here we can see the curve for the hybrid concrete slab, LVDT1 and LVDT2 at failure. For conclusion, the use of hybrid concrete had a very large effect on the shape of failure by slightly decreasing the dimension of failure for most of the specimen compared to the control specimen. The amount of scattered pieces and cracks generated by impact was decreased because of the reactive powder concrete as a top layer worked on absorbing the impact. The use of hybrid concrete helped increasing the resistance by producing lower deflection. It decreases the deflection by 11.4 at LVDT1 and 12.8 at LVDT2 for control for first drop, and 12% for LVDT1 and 11% for LVDT2 at the second drop. Thank you.